So this is multiple choice topic 2, number 27. Let's see. Second derivative at 0. So, yay, it means we get to take a derivative twice. And this looks like a product rule. So y prime, we'll say the first one times the derivative of the second one. Times 1. I didn't really do anything, but I'll put it there to sort of emphasize. Plus the second one times the derivative of the first one. And then we can clean that up a little bit. In fact, that cleans up quite nicely because e to the x minus e to the x goes away and we're left with x e to the x for our first derivative. But we want the second derivative. So we'll do product rule again. So second derivative is the first one times the derivative of the second one plus the second one times the derivative of the first one. And as always with e to the x, it's a little bit, they look goofy because the derivative of e to the x is e to the x. And so you kind of get lost on, wait a minute, did I take a derivative or not? Because it's the same thing.
Where did you get x e to the x?
From right here, if I multiply this out, I get e to the x plus x e to the x minus e to the x.
Oh, okay.
And so the e to the x's cancel. And that would be the rare case where I shouldn't say rare. The derivative is simpler than the original. But then the second derivative is a little bit more complicated. So if we plug in 0, 0 times e to the 0 plus e to the 0, well, that's gone, and then e to the 0 is 1. So my answer is D. So product rule twice, knowing e to the x, and then some algebra in there to make things a little bit easier. What other questions? $30? Okay, a couple ways to work 30. So there's a short way that doesn't always work, and there's a more complicated way that always works. That's my conundrum on this one. I say we do it the easy way, although they can rig the problem that forces you to do it the hard way. H is the inverse function of f, and f of x equals 1 over x. So that means for h, inverse means x and y switch places. So for the h function, x would be 1 over y, which means y equals 1 over x. So 1 over x, if you take the inverse of 1 over x, you get 1 over x. So that's a little bit weird. It's good news for this problem, but that's a little bit weird. So h is 1 over x, which is x to the negative 1. So h prime then is negative 1 x to the negative 2. So h prime of 3 would be negative 1, 3 to the negative 2, which would be negative 1/9. So B. On 28 and 29, they want you to recognize that instead of actually doing those limits, that is actually the definition of the derivative of, remember the definition of a derivative is f of x plus h minus f of x all over h as h goes to 0. So they're wanting you to recognize that this is the derivative of 1 plus h to the 6th. So that's a little bit tricky, but it makes these limits manageable. So there's its derivative, and then we'll plug in 0 for h, and so we'd end up with 6. Same thing with 29. They want you to take the derivative of 8 plus h to the 1/3. So that'd be 1/3 8 plus h to the negative 2/3. I didn't finish that one. I plug in 0. 1/3 times 8 to the negative 2/3. Let's see, 8 to the 2/3. Cube root of 8 is 2. Squared is 4. Negative flips it over. There's a whole lot of algebra in there. But 1/12. Because I don't know that there's an algebra way to handle those. I think you have to recognize that that's a derivative that they're secretly asking you. And so that's sort of the hint that you're trying to take a derivative, or they want you to take a derivative. Most of you didn't get there in class yesterday, but are you okay with the table problems? Most of them are pretty easy, just we haven't seen one in a while. You're like, oh, there was the third page. Let's see, which would be the hardest of them? Probably 34, because that looks like a chain rule problem. So chain rule is the wrappers, right? Start from the outside and work your way in. So starting on the outside would be f prime, but you can only eat one piece at a time. So you leave the g of x alone until you're done with f prime, and then you chain rule that times g of x. I think that's the hardest of the bunch. The rest are product rule and quotient rule, so they're not too bad. So that means m prime of 1, f prime of g of 1 times g prime of 1. And then we got to go to the table and figure out what all those values are. So g of 1 is 3. G of 1 is 3. That's where that 3 came from. F prime of 3. So f prime at 3 is 4. And g prime of 1 is negative 3. And so my answer, I hope, is negative 12. And yeah, that's one of the choices. Oh, let's do 35. Then we'll be done, because that's the long way around on the inverse thing. If s is the inverse of f, then s prime of 3 equals. Okay, so f. This is where we set this table up. So I want the derivative of s at 3. That's where I'm headed. But do you remember that these two things are reciprocals? That's sort of the main point of this problem. So I need to figure out what this point is, then what his derivative is, and then I'll flip it over and that'll give me my answer. So that's one of the trickier things we do all year, is this change is with inverses, because x and y trade places for inverses. So s prime of 3, that means 3 is the x value for s, but that means it was the y value for f, because they trade places for inverses. So look at the table. What value of x has a y value of 3? So I'm looking in the F column. F is equal to 3, so the y value is 3 when x is 1. Follow the steps here. Then f prime at 1 I can get from the table is 2. And so the answer I'm looking for then is 1/2. Man, that's tricky to follow. That's always one of the trickier things to remember and figure out. And it's frustrating because there's no hard derivatives to remember, usually. There's no hard formulas. There's no hard algebra. It's just remembering to switch the x and the y and all those steps in there. All right, with the rest of the time, let's do topic 3, multiple choice topic 3. There's 24 of those questions, which means that should take you 48 minutes. We have 40 minutes left, so you may not get to all of them, but maybe some of them go quicker. Maybe you have a little bit left over.
No.